Hey, it's Mr. Stolatano, and today we're going to practice forming binary ionic compounds using the crisscross method. So the first thing we're going to do is we're going to find charges of the elements on the periodic table. Then we're going to crisscross those charges to form the compounds. And then we're going to reduce the formula of the compound to its simplest possible form. So at this point, if you have a periodic table, you may want to take it out to follow along. So here's our periodic table of charges. Now what I'm about to show you is the format of problems you can expect to see in class. So for example, we could start with calcium, and we're going to form an ionic compound using chlorine as well. Now again, the first thing we do is we look up the charges. So calcium, right here, is a +2 charge. So we put the +2 right up there. And chlorine is a -1 charge in that column. So we put the -1 up here. Now what we've done in the past to show what this kind of looks like is we'd make a puzzle piece that would have calcium, the 2 plus calcium ion, and then we have a couple of relatively smaller pieces of chlorine ions, each with a 1 minus, that would cancel out that calcium 2 plus, and this would make a neutral ionic compound. So our formula, now see we'd have 1 calcium, so we don't put a number, and then we have 2 chlorine, so we put a 2 after the chloride ions. So this is our formula. But this isn't the skill we're going to be working on today. Today we're going to be working on a shortcut on how to do this. So what I'm going to do real quick is go ahead and erase this. And then we're going to show exactly how to do the new form, which is called the crisscross method. Now, in order to do the crisscross method is exactly how it sounds. So the first thing you're going to do is you're going to take one of the charges, so we'll take the 2 plus in calcium, bring it down, crisscross it over, and then we're going to grab the other charge and bring it down the other side. Now this is our shortcut, so when we finish, we're going to have 1 calcium and 2 chlorines because we brought that 2 down to the side, and we don't show the 1. Now this is how we're going to form this so that we have a neutral charge. So we did it correctly because our charges have canceled. Okay, now let's try out another example. This time we're going to use magnesium, and then we're going to use oxygen. Now if we look over at the periodic table again for charges, we find that magnesium is in the second column, so it would be a +2 charge. And oxygen is right here, so it will have a -2 charge. Now the next step, we crisscross these charges. So we bring the 2 across, and then we also bring the other 2 across. Now what we immediately get from this will be Mg2O2. Now intuitively you can probably see that this is not completely correct, right? This is not the shortest formula we could get with this. This is not the simplest form. We know that it would actually take 1 magnesium to cancel out 1 oxygen. So we're going to go ahead and cancel out these 2's because they have a 2 in common, and then we end up with MgO. And this is the actual correct formula. So we have to make sure we reduce by finding a common factor. Okay, so let's try another one out. So this time we're actually using a metal that comes from the transition elements. So this is from the vary section in the yellow there. So there's going to be an important distinction we have to use with these. Now we know that chlorine is in the -1 column, so chlorine will have a -1 charge. But the charge of the iron varies. It could have multiple charges, so your teacher is going to have to give you the charge. Now this time I'm going to go ahead and say that this particular iron has a 3 plus charge, or a +3 charge. So we can go ahead and make our formula. Now this would just come out to 1 iron and 3 chlorines once we crisscross. That would be the correct formula. Now what I'm trying to emphasize here is that you could also have a different type of iron, and this iron could have a +2. This happens in real life. And in order to do this type of problem, you just do the same steps, but our formula will be very different. This will be FeCl2. So it really makes a big difference what charge that transition element from the yellow section is going to have. And so it's very important. Okay, so then we look at another example. This would be our last example. So we're going to go ahead and take tungsten. Tungsten is another transition element, and then we're going to cross it with oxygen. Now we know oxygens are -2, so we can go ahead and do that. Now again, your teacher will have to give you the charge of tungsten because it could be many charges. In this case, we're choosing a +6. So we go ahead and do the crisscross for this one. Grab that 6, bring it over. Grab that 2, bring it over. And we're going to end up with W2O6. And we see that this is not the simplest form. So the common factor here is 2. So if we divide the 2 by 2, then we're going to end up getting 1 tungsten. And if we divide the 6 by 2, we'll get 3. So our final form is going to be WO3. So now let's take a minute to test what we've really learned in following this video. So here are a couple of elements, sodium and fluorine, and here's the formula that we're claiming they would make. Is this the right ratio? So pause the video for a minute and ask yourself, is this the correct ratio for these two elements? And the answer is yes. Sodium is a +1, fluorine is a -1. They would be a 1-to-1 ratio, so this is the correct answer. Let's look at another one. Strontium and sulfur. Do they come together to form this ratio? Pause the video and see if this is the correct formula down below. Now the answer is this is actually not the correct formula because remember we have to reduce properly. So because they have a common factor of 2, you can divide both 2's by 2 and you'd get 1, which gets the SRS formula. So the correct new formula is actually SRS. Let's try another one. Is this the correct formula that would be formed? So pause the video and see if you can answer this one. This is actually not the correct formula, so this is a common thing that people sometimes forget to do, is that, remember, the 2 has to come across, and the -1 has to come across the other way. So the correct answer to this is actually CuCl2, because remember, you crisscross them. You don't just bring the charges down, but you crisscross them. Now, one more. Now, with this one, we've been given the charge of chromium, because chromium is a transition element. We're given a charge of +6, and we're going to have to find the charge for nitrogen. Now the question is this the correct formula that would form with these two elements? So pause the video and see if you can figure it out. Okay, the correct answer is actually no, this is not the correct formula. This is what the correct formula would look like. And the reason is because we actually did use the right charges. Nitrogen is a -3, so we crossed that over. Chromium is a +6, cross that over. But it's not reduced yet, right? So to reduce it, both of these numbers are divisible by 3. So we divide the 3 chromiums by 3 and get 1. Divide the 6 nitrogens by 3 and get 2 to get the final formula of CrN2. And I hope that's been helpful.